Welcome to the session on transportation analysis. I'm Austin Chamberlain. I work with North Carolina Department of Transportation in the GIS unit. First speaker we have here today is Dermis Sesser. Dr. Sesser has more than 26 years of experience in engineering, IT, and project, program, and strategic management fields. He's been working as an application support manager at the Durham Chapel Hill Carborough MPO currently. He has worked in private, public, and academic sectors nationally and internationally at various roles and capacities. He is a licensed professional engineer in Texas and has project management professional certification. He's a certified floodplain management CFM certification, GISP and Esri Enterprise Associate and ArcGIS Desktop Associate and Professional and CompTIA certified trainer certifications, and has been teaching Esri certified and other GIS classes since 2003. He is a reviewer in several journals and committee member and advisor in GIS, IT, and water-related organizations. He has been awarded various awards in GIS, including Special Achievement in GIS in 2004 and 2014, and is listed as a GIS expert in Who's Who of America list since 2009. Please welcome Dermis Sesser.
Thank you, Austin. Good morning. How are everybody feeling today? Hopefully good. And then you are having good sessions every single, essentially in the morning, and then you are going to continue with the good ones as well, better ones, hopefully. My name is Dermis Sesser. As Austin mentioned, I'm working with the Durham Chapel Hill Carborough Metropolitan Planning Organization for about 4 years as of now, and dealing with the transportation planning related, operations related, and modeling related data, application, database, and other support like standards and other support issues in a nutshell for the whole organization. We are hosted in the city of Durham, but we are a kind of a separate entity. In other states, you are going to see these MPOs as a separate entities on their own without being hosted here and there type of a deal. But here, the organization they are kind of hosted in the city, just to kind of set up some kind of initial background as to where I work, what I do. And what I'm going to talk today is enterprise GIS in traffic data management, especially traffic issues, traffic congestion and other issues like safety, congestion, counts, you name it. ITS is a part of it as well. And then we are going to talk about our current implementation as to what's called GIS data management portal. That's what I'm going to be talking about. It's still in progress, but we are kind of getting a hands on it, and then we are going to be completing by the end of this fiscal year, which is July. That's what we are expecting to complete it by then. And then I'm going to talk about what we are planning to do in the future as it pertains to the traffic data management using what's called various technologies, including the databases, including the GIS, including the web, and other components. I would put it that way, and then conclude with some of our findings, based on what we are implementing currently. First of all, I'd like to get into a little bit traffic data. When we say traffic data, what we are talking about, just to clarify what we are managing, first place. And traffic data, definitely one of the things we are going to be taking care of with the traffic data would be the counts. How many vehicles using, what kind of vehicles, what kind of speeds are we talking about as to what's called essentially transportation network is concerned. That's what we are going to be looking at, one of the first primary things as to traffic data count part, or traffic data part. The second one is turning movement counts. How many people how the intersections has been used. How they are functioning, put it that way, to understand it, we are counting what's called essentially intersection turns, right turn, left turn, straight, through passages at the intersections, and spot speeds, delays, gaps, and saturation, etc., as to the intersection movements are concerned. And then the third major thing, I would say, travel time. How long does it take to get from A to B, and then associated statistics and classes and types. And then fourth thing, we are dealing with non-motor, sometimes we call it pedestrian and bike counts, essentially how people are using what's called the essential transportation network or the vicinity. It doesn't need to be connected with the road network, essentially. It could be a trail, for example, how it is being used, and then how many people using, as to the bikers or pedestrians are concerned. And then fourth thing, which is in these days, especially one of the major issues, or federal government, as far as I know, lately has zero accident, incident initiative, we have been pushed out, like traffic safety and accidents, and then how we could kind of incorporate the latest technologies to alleviate the traffic safety and accident and safety issues essentially throughout the like transportation networks, throughout what's called our transportation roads and other stuff. And how we could reduce the accidents, how we could reduce the incidents, how we could reduce the what's called fatal ones, especially, you know. That's a kind of major concern at all times, actually. But in these days, especially, there's a push for it, you know. Do whatever you need to do, you know, to get what's called zero level or minimize it. And then transit services like public transportation we are talking about, even though it's not as extensive as we would expect, you know, in these areas or in the other areas in the U.S., but, you know, especially in some of the areas, we are definitely seeing what's called there is a trend or there is a move, there is a what's called requirement to, like, you know, use the public transportation means, like transit, essentially, as the main form of a transportation. Like in this area, I mean, you can't use your car. I mean, I should say that. I mean, like when I first went to the DC with my car, with the car, you know, company car, essentially, I felt like I better get what's called another room for my car. That would have been much more cheaper than parking here and there, to be honest with you. And after I saw, you know, there is no way. I mean, you can't use it like in the city traffic. There is no such environment. And then like in these days, especially including the federal, state, and local governments in the area, for example, promoting the telework. And they say this is kind of giving as a, how do you say, perk to the employees, but I feel like it is not a perk, it's a necessity. I mean, I couldn't even imagine if everybody was on the roads. I mean, you can't, there's nothing to manage it. Everything stops like still, you know. That's what it felt like. And then we are getting the same levels here as well, you know, as you would expect, especially in this triangle area. And then other things kind of we deal with as to traffic counts, mobility. You know, how mobile we are getting, how we kind of, you know, how we are speeding the what's called transfer of the goods and people and the goods to the what's called to the new locations or to the locations that they need to get to, you know, origin to destination, what's called flows, how we are doing, congestion issues, why this is happening, when it's happening, you know, at what roads or the regions or the what's called network pieces, essentially this is happening. And then another issue like we are dealing with as to the traffic counts compliance, you know, how people are compliant with what's called rules, regulations, and other stuff essentially as it pertains to traffic, sorry. And then of course, GIS is one of the technologies we do use, I mean, as you would expect, as the kind of a, you know, conference's main team, like to manage the traffic data. GIS is about location, first thing to say. I mean, in my opinion, I mean, I expressed like several times in several conferences, if your GIS is not answering the question of the location, your GIS is just a garbage, nothing more. It's a waste of your time, waste of technology, waste of whatever you call it. But if your GIS is not answering the where question, it's useless. That's it. Where things are happening, you know, in a nutshell. And then one of the things, kind of as we would expect, where things like visualize, show me where the accident's happening. Like the last year, the year before, this year or in the future, where we are expecting, you know, like futuristic, what's called essential scenario as well, we are talking about. In 3 dimensions, 4 dimensions, even real time, you know, as things kind of flow. And then analysis, you know, how we are going to be what's called essentially finding out the root cause of the issues. Is the signal issue? Is there what's called the pedestrians or what's called bikes are passing, like, you know, haphazardly, let's say, or using the intersection haphazardly? Or the, like car drivers are careless, or what's the issue? You know, what's the root cause of the issue? In order to kind of find out the root causes, we need to analyze the data, what's happening, and then to get an insights or what's called to get a feeling about the, you know, what's happening, what's really happening, and then decision support, what we need to do. Okay, we understand what's happening, what we need to do, like based on what's happening. Do we need to kind of install a new sign? Do we need to put up some kind of a new light, or do we need to do some roundabout or something else, you know? And then, of course, field data collection and integration of the field data is a critical part of what's called traffic data management in GIS. You know, be incorporating the field data in real time as much as possible with the QA/QC incorporated, of course. I'm not saying kind of just dump it in whatever it comes from the field, because I have seen quite a bit of examples in the real life implementation. When we are implementing the portals, we saw, you know, man, you name it, anything and everything is possible. And I'll share with you, I mean, you know, in real life, yeah, it's supposed to be this, but nobody applied this. Okay, this is something else. The cases kind of appears. And reporting, finding out, daily, monthly, yearly, or 5-year span, 10-year span, like in a planning horizon, 20-year span, what we are expecting as to the traffic situation is concerned in our region. And then, of course, one of the critical pieces, especially in the transportation planning and other planning efforts in general, partner-public engagement, making sure that your partners understand what's being observed, and they are working in coordination to alleviate the issues. In the Triangle region, as we all know, we are partnering with what's called local jurisdictions, we are partnering with the NCDOT, we are partnering with the other entities like regional entities, and then we have to, because it's not something like restricted to a certain area. It's happening in the network. Things are linked. An accident happens at the what's called Durham-Wake County border, would be affecting the traffic in Durham County, would be affecting the traffic in Wake County, would be affecting the traffic in the Orange County. There would be cascading effects of the what's called essentially the things happening in the network, in a nutshell. So we need to understand that. We need to engage the people to alleviate the issues collectively instead of just creating some kind of one-of-a-type solutions, which doesn't solve anything. Actually, it transfers the issue to someone else. That's what it does. And then, a little bit about ourselves, we are kind of a regional organization dealing with the what's called established by the federal mandate in 1962, and then coordinating the what's called urban areas transportation planning efforts. As part of our efforts, of course, planning efforts, we are doing the what's called planning, modeling, and then operational studies as well at the same time, as you would expect. And then we are kind of, we have our own board, we have our own technical committees, subcommittees, and then participants from local government and state government agencies as well. And then our urban areas include the Durham County, Orange County, parts of the Orange County, especially Chapel Hill and Scarborough region, and then Chatham County, parts of the Chatham County as well included. And then with that, I'd like to kind of get into what we are collecting, and then what we are trying to serve. This is the kind of gazillion of data, millions of points, you name it, has been collected for over the years. And then we need to kind of make it available, accessible, usable, understandable by the public and by the partners as well, to a degree possible. One is ADT, average daily counts. Of course, when you say average daily counts, there are variations of it. AWDT, for example, AADT, for example. ADT stands for average annual daily traffic, with the factors applied, with what's called certain seasonal corrections applied, whatever, to see what's called not only daily trends, but also monthly, yearly, 10 years, 20 years trends, essentially. And then another one, travel time. When we say travel time, we are talking about the routes, trajectories, essentially, from A to B. Of course, there are certain routes kind of to be used by the what's called drivers, and then we need to account for it. And then we need to be talking about the cruise speed data, all this stuff, essentially. The other one is TMC. We are collecting, turning movement counts. Non-motorized counts, we are collecting safety data, accidents, and then what are the costs of the accidents. Is there any injuries versus fatalities? Essentially, we are kind of definitely investigating, analyzing, and collecting all that information. And then APC data, automated passenger counts, how the what's called transit system is doing, how they are performing, and then finding out what's called stop information, finding out what's called route information, finding out the segment information, and then performance trips, number of trips, for example, cost of the trips. People traveling, number of the people traveling or using that routes. And then we have quite a bit of special collections as well that has been carried out to look into the issues in certain localities, especially. Let's say high dense areas or the areas that we are expecting some kind of high development. We are looking at to what's called specific locations in our jurisdiction as well. And then, of course, when we say traffic data, we are talking about the spatial location is one of the fundamental pieces. And then when it comes to the traffic data, we are talking about the more of point measurements. We are talking about the line, segment, link measurements. We are talking about the route measurements, essentially. How things are changing along the network or network pieces or subsets or, at the stops, for example, at the what's called route segments or the routes in the case of buses, for example. And then we are talking about the time resolution, temporal resolution of the data, range interval, AM peaks, PM peaks, noon peaks, throughout the day, how things are changing throughout the season, how things are changing. We are collecting the data like in fall, collecting the data in spring, collecting data in winter. We have to find, in order to find out the seasonal variations in the traffic patterns, essentially. And then point in time, what's happening, and then average, like statistical averages of what's called essential data being collected for a day, for example, for a month, for example, for a year, for example. We need to kind of consider these as well, temporal resolution of the data. Other than that, we are considering the data details. What has been collected? What specifically, what's called essentially being gathered at that location for that part of that mission. Data attributes, for example, data resolution again, data quality, how precise we are, as to the collection locations are concerned. And then collection counts are concerned, how correct, how quality, how reliable are these collections are, That's what we are looking for. Other than that, of course, we are creating tons of summaries out of the data. Travel time index, for example, level of service, for example. ADT is another what's called statistical summary with certain seasonal factors being applied. Confidence, mean, peak hour volumes, peak hour factors, and other stuff essential to understand the overall, how the traffic is changing, traffic patterns, traffic designs, traffic, situation overall, like it has been modified throughout the years, throughout the hours, throughout the day, throughout the season. Of course, like when we say data, in my opinion, again, my opinion is the following. There is no data as error-free, actually. Let us be honest. Whether it's a GIS data or non-GIS data, like temporal data or some other data, whatever. In my opinion, I'm personally, error is an intrinsic part of the data. You can't avoid it. But we have to minimize it, definitely. I mean, it doesn't mean that let it go. No, I'm not saying that. Don't get me wrong. But you need to realize that, for example, GIS is a representation of the reality. It's not the reality itself. You need to realize that. Or what we are counting has, has tons of issues with it, Like, observer errors, counting errors, time errors, climate errors, whatever, you name it. There are tons of factors goes into what's called data collection efforts and how it is being collected. Tons of errors kind of induced or injected or became a part of a data in a nutshell. So we need to identify these, like unique, consistent, reusable IDs, like for the stations that we are making the measurements. Missing data gaps. There are cases like that, definitely. There were cases. As we process the data, we realize, oh, man, holy smokes, what we are doing. That's what you start to say. Missing attributes, details. Like some of the data collected properly, some of the data hasn't been collected properly, They didn't do the right job or the good job, put it that way, and it was in the past. So what am I supposed to be doing? Filling in myself? Just guessing? Flip the coin and then, say this is them? And then different data formats. Everybody has its own unique ways of collecting the data, like what to collect, how to collect type of a deal, and then you need to account for it. And then different data accuracies. What kind of measurement tool used definitely determines the accuracy level of the data as well. And then there are tons of errors, mistakes being contributed by the what's called technicians or the collectors, essentially, or others like us, for example, like as we are processing the data, And then data reconciliation, augmentation issues. Of course, you are not after just representing the what's called single data records in a time. You are representing the whole slew of data sets, essentially. You need to reconcile and then bring them into the what's called some kind of a common structure that's meaningful for all these records, essentially. That's what I'm talking about when I say reconcile augmentation. And then what are the, other than the data, we have, kind of a, what to serve issue. Stakeholders doesn't want every single detail, for example, as to the data. They need to, some of the stakeholders requires what's called data as detailed as possible. Some of them, just give me the general picture, what I'd like to see. And then some of them, looking for what's called much more technical details of the data, how it's being collected, what it represents, what it means exactly, with what's called raw data itself even, accompanied to the data. And then what we need to decide when we are implementing the data portal, what data needed, what to serve, essentially. We need to do what's called how detailed we are to serve, or what details to serve to whom. That's what we need to decide. And then how to serve. What are the mechanisms or what's called technologies we are going to be using, that would be best for our region or for our what's called essential purpose. And then some of the things kind of we have taken care of, for example, unique IDs. We need to assign what's called, in certain cases, we had to assign the unique IDs to the what's called our records and then adopt some kind of unique ID generation schema. And then we kind of, did the corrections as to the details of the data or resolutions of the data. For example, where do you assume the station is? Like when you are making the, let's say, average daily traffic counts, like sometimes technician is here, sometimes on the other side of the street, sometimes 500 feet away. So what would be the representative station for that section? That would be a concern, and then you need to kind of resolve it. And then further customizations, and we need to be doing some kind of a custom, like create the custom features in case needed, like as requested by our end users, and then we need to kind of provide a better user experience. They should be able to see the same facts, same realities across all the platforms, essentially, whether it's a mobile platform, whether it's a what's called desktop platform, whether it's over the web. So you need to kind of provide a good experience for the users so that they're going to be able to use it and understand it and consume it properly. And of course, one of the things, you need to understand the business process, what goes into the what's called essential data collection, how it gets there, before you kind of put it into the portal. And then read through the manuals, protocols, standards applicable to data collection. What's the standard we applied, for example, for that effort, for that year? You need to understand that so that you are going to be reading the right data in. Otherwise, okay, I'm going to assume this is being done, or what is stated in the standards has been applied exactly. You're not going to find it, I could assure you, in anywhere. I don't think that DCAC MPO is an exception. Everywhere is the same. Go through README files. Sometimes, improperly, or how do you say, inconsistent, or to a degree, kind of, things are reported, there are issues with these measurements, so we have to recollect. So you need to discount these measurements or counts, essentially. And then know about the data collection effort, formats, data structure, tools, and processes applied. In certain cases, like we are using the videos in order to kind of get the counts. In certain other situations, we are using, manual counts, or we are using some other tools. You need to kind of know these data-specific, collection-specific tools, essentially, and then how they collect the data. And then you need to kind of, QA/QC the data, definitely, and then you need to kind of, report the issues, and then for the what's called traffic engineer or our expert, essentially, to decide, what to do with it. And then data migration as well is a part of our portal development process. And then we have used, like when it comes to the what's called essential data migration, we try to kind of observe some kind of standard format being applied, and then we automate the process as much as possible. We don't want to do it like one at a time processing, or like migrate the record at a time. That doesn't make sense. But the issue that with the original formats, original data collection, forces you to go through first, to understand what has been collected, how it has been collected, and then whether it is kind of compliant with the requirement or this protocol being set up at that year for that collection. You need to understand that before you kind of start automating. You need to kind of do some manual massaging, feeling about the data, essentially, first thing, to automate. And then tools available, When it comes to the what's called automation, there are gazillions of tools available. What will be the best, like in your scenario? Depending on the original format, depending on the structure, depending on the complexity of the processing, you are going to be using tools, And then eventually we are after, like, developing something that's robust. It's not just, script-based, whatever deal. We are looking for, like, that application that could take care of, like, various scenarios, various possibilities, provide the flexibility to the end users or processors of the data. And then with that, I'd like to kind of demonstrate our system, if time permits. And then I have it open here. And this is kind of what we use essentially currently, but we have our own internal development as well as part of what's called this collection. This is, sorry, it's not showing. It's not showing. Okay, this is our system, essentially. We have been using in order to collect and disseminate the average daily traffic data and associated derivatives. Essentially, with that system, what you could do, like search for the data. First of all, I'd like to enable some of the visualization stuff so that you could see where we are collecting the data. I'm going to click on the tool, and then traffic count database system. go here, and then you are going to see a bunch of dots over there, and then zoom into the what's called map to see like a little bit further details. For example, like if you look at the what's called these points, what has been collected on that point, essentially we could see this Hope Valley Road, and then with the intersection of south of Martin Luther King Boulevard, and then over that point, this is the data being observed. For example, 2005 to 2013, data has been collected, appears to be collected. And then this is kind of an average, annual average daily traffic counts, essentially, we do see. And then this collection seems to be containing what's called two-way bidirectional counts in a nutshell. That's what you could see. Or with some other tool, for example, if I go back to the home, and then with the advanced search tool, for example, I could specify the count type. For example, I could specify whether we have the detailed counts for that location or not type of a deal. Volume count, whether we have what's called volume counts and other counts, yes, for example, like specify over here. And then like we could specify the jurisdiction information, for example, let me say, for example, all for the time being. And county information, I'd like to select some location in Durham County. And search. Since we ask for what's called detailed data, we are going to see what's called essentially edited data with the associated details. If you click on these eye symbols, for example, next to the measurements, you are going to see what's called essentially hourly counts at the background, not daily summaries in a nutshell. And then in our TDDS system, since because of the lack of time, I would like to kind of a little bit browse over. What we use at the background is here data, but we are planning to incorporate our trajectory data for the travel time measurements. And then you could specify the year or day of a week. You could specify what's called essentially whatever day you are interested in. You could specify the what's called month of the year, for example, March. And then you could specify the functional class types for the roads, essentially to show the information. And then with that information, you could see like in 2015, during the morning, what's called rush hours, in March, Wednesday, essentially, these are what's called congested locations, like travel time index is higher than 1 in a nutshell. As you could see over here, for example, at the intersection of the I-40 and Fayetteville Road, I will put it that way. Or like 55 and I-40, for example, right here, like with the 54 and I-40 intersections, we are observing issues. This is kind of this system is still under development, and then we are still working on it, as I expressed, and then we are trying to make it better. We will make it better through what's called essentially better understanding the needs, requirements, standards, protocols. And sorry about it, looks like it's bad. Better integrated responsive real-time applications, essentially. We are trying to incorporate the real-time data as well to our system. Better customized platforms, better user experience, like people would be able to access the data, information essentially from across all platforms. Standard policy protocol updates to alleviate the issues that we are observing essentially as it goes by, like throughout the year's collection. And then an expansion and enhancement of the collection efforts to do it properly, do it more completely. And then support and training would be part of our what's called traffic data portal implementation. With that, I'd like to kind of I'd like to kind of open the ground for the questions, if there's any. Yeah.
What's your method for collecting time
Travel time data collected, there are multiple methods essentially we are using, as far as I'm concerned, as far as I know of. One is kind of what's called essentially like, technician kind of driving the car around certain routes, being specified, trajectories being specified, and then, getting the counts. And then we are getting what's called some air data you may know, more than likely, like, through the cell phones, essentially collection of what's called travel time information. We are using that one as well to augment what's called what we are collecting at a time, at certain time. There are various methods essentially in a nutshell. It's not just one. Because we are after, like again, certain methods like fits to what's called certain time frame or certain what's called route. we are after filling the gaps and then getting the what's called continual picture of the how this overall network system operates. So we have to accommodate multiple systems, multiple tools in order to collect all that data.
So when you say you're collecting some of the data, where are you getting that?
Air, as far as I know of, Air, like there is a company who augment all that data essentially. And then other than that, there is what's called here, as you know, more than likely they came into the what's called US and collecting extensive data from various sources. And then we are using that platform, as I showed over the what's called demonstration. Like at the background, there is a here data as well. And then we are trying to get into the real-time collection as well at the same time. ITS, components too. Any other questions? Okay, thank you. Thank you. Sorry, can I grab the mic? Yeah, sorry.
All right. So for our next presentation, we've got 3 speakers. I'm just going to go ahead and start announcing them while they're loading their presentation. We've got Steve Burt, Alyssa Randall, both from Planning Communities, along with Brandon Watson from the city of Raleigh. Steve got his bachelor's in economics from the University of Illinois, Champaign-Urbana, and his master's in transportation policy, operations, and logistics from George Mason University in Arlington, Virginia. He spent 3 years working as a research assistant at ITRI and at NC State, and has worked as an economic analyst for Planning Communities for the past year. Steve conducts economic and fiscal analyses that include evaluating how transportation investments impact their region's economies and their residents' quality of life. He has conducted efficiency reviews, revenue-generating studies, and economic contribution, economic impact, and cost-benefit analysis for transit, rail, bike ped, ferry, and highway investments in North Carolina. Alyssa received her BS in Geography and undergraduate certificate from GIS from ECU, and her MS in Geoscience and grad certificate in GIS from the University of North Carolina, Wilmington. There she mapped the nesting patterns of loggerhead sea turtles, and her graduate work earned her the Herb Stout Award at this conference 2 years ago. She served as a sea turtle biologist for North Carolina Coastal Reserve in Masonboro Island and the Bald Head Island Conservancy. She now works for Planning Communities in Raleigh, conducting environmental impact analysis mapping for transportation projects. Brandon's with the city of Raleigh. Brandon attended Appalachian State and graduated with a Bachelor of Science in Community and Regional Planning and Geography. Brandon worked previously with the CRASH program in traffic engineering with the city of Raleigh for about 3 years. He's been working as a transit planner for the city of Raleigh Transit for about 1.5 years. He helps plan bus route changes and heading into the new Wake Transit Plan, as well as dealing with existing bus stop data, including GIS, route planning information, and adding or maintaining passenger amenities. So please welcome our next speakers.
Thank you very much, Austin. Hi, everyone. I'm very glad that you were in the room today. I feel honored to get to share this space with you. Before we get started, I just would love if at any point during our presentations you have an idea, question, or any input, please jot it down because probably the best part about the opportunity here today is to learn from all of you. So my name is Steve Burt. As Austin had said, we're here today to talk about the economic benefits of transit. Mainly we'll be talking about how can we quantify the monetary gains that transit provides to its ridership and region. I will be discussing the different types of economic benefits that transit provides and a model that can be used to quantify these benefits. Brandon will be discussing why economic considerations are important for the city of Raleigh. And Alyssa will be talking about where we go from here. What are some of the next steps? Bringing it into context, how important is transit as a travel mode for individuals across the United States? In 2016, nearly half of our nation's states put a transit ballot measure up for a referendum. And of those ballot measures, approximately 2/3 were approved. So that's the voters in those regions willingly opted to pay more in sales tax, property tax, or other measures to support enhancements in transit. If you take a look at the map, the red pins, those denote areas where you can see sales tax increases, the green denote property tax increases, and blue are other measures. As most of you in this room may know, Raleigh was one of the regions that put a sales tax measure on the referendum during the 2016 ballot cycle, and it successfully passed. 53% of voters approved a half-cent increase in sales tax, and in addition, an increase in vehicle registration fees. By fiscal year 2018, there should be approximately $85 million in revenue available for transit and rail projects across the region. Now, because that referendum was successful, Raleigh's warehouse district is quickly becoming a multimodal hub for the region. If you take a look at the triangular parcel, that white building in that parcel will become the new Amtrak station. And then if you follow that arrow, that's the old Dillon Supply warehouse building, and that's going to become the Raleigh Union Station bus facility. Both facilities are expected to have office space in it and potentially apartment rental space that can generate additional revenue for Wake County. So amidst all these exciting investments that are going on in Wake County, there have also been substantial advancements in the academic world. And the Small Urban and Rural Transit Center had released a groundbreaking study in 2015. It was published by the Transportation Research Board of the National Academy of Sciences. And this study really made two things possible for transit planners across the United States and really around the world. The first was that it put forth a methodology that transit planners could use everywhere to calculate the economic effects of transit. And then the second thing was that it showed that without transit, some trips would just not be taken. So in the absence of transit, many people would find their ways to destinations with other modes. So for example, they might take a car, get a ride from a friend, bike, walk, or hail a taxi or Uber. But 1 out of 5 trips would just completely disappear. They would not be made because people would not have the convenience or low-cost option of transit. So as I mentioned on the previous slide, CERTSI had developed that methodology that makes things possible for transit providers everywhere to look at the economic effects of transit. There are two main sort of branches to think about when looking at the ways to quantify the economic effects of transit. There are economic impacts, and those come from any sort of expenditure that's made. So think of a transit agency might have a capital or operations expenditure. Any sort of expenditure that's made, that money circulates through the economy and supports jobs, wages, gross regional product, and additional tax revenue. And now there's another side, the wider economic benefits. These are the benefits that everyday riders that use transit get to experience. So they, instead of taking other modes, may experience savings that are presented in vehicle operating costs, travel time, emission, collision, or congestion savings. And then also, I mentioned before those trips that could potentially disappear. Transit offers trip generation benefits. Those induced trips enable people to make medical trips, go to work, and they enable people to go to shopping destinations or seek out social and leisure destinations. Now, just kind of digging into that methodology a little bit more, if you can remember on that one side, there was the traditional economic impacts. These impacts are modeled through input-output models. Some of you in this room may have heard of
InPlan, Tretis, RIMS2, REMI. There's a bunch of models that can be used to look at traditional economic impacts, again, how those expenditures filter through the economy. And those have direct, indirect, and cumulative effects as they circulate through the economy. So to give an example, let's say Go Raleigh was interested in purchasing a bus that would operate on the R line. That purchase would help support the earnings of a bus manufacturer directly. And then indirectly, it would help a supplier who would provide materials to the manufacturer. When the bus manufacturer and the parts supplier take their earnings and spend it in the regional economy, let's say 2 staff members, one from one bus manufacturer, one parts supplier decide, let's go out to our favorite restaurant and spend it. That provides a cumulative impact where it's supporting earnings for a staff member at a local restaurant. So these are the ways that traditional economic impacts work. There's an expenditure. That expenditure circulates through the economy and supports jobs, wages, gross regional product. Now on the other side, there's wider economic benefits. And again, these are the benefits that riders feel. So someone may feel less vehicle operating costs, time savings, congestion, emissions or collision savings. Or additionally, with those induced trips, they'll be able to take medical, shopping, work, or leisure trips. Now, I apologize that this slide is very busy, but I would like to use vehicle operating costs as an example for how the model works. And I assure you it's not as difficult or complicated as it may seem on the slide. Basically, you're just looking at what the costs an individual would incur taking transit versus the cost that they would incur taking a mode that they would choose in the absence of transit. So for example, Go Raleigh has an estimated daily ridership of around 23,000 people. So if those individuals tomorrow were told, bus service stops, we're no longer providing that service, 13% would choose to get to their destination with a vehicle, 12% would, with a personal vehicle, 12% would taxi or take an Uber, 23% would get a ride with a family member or friend, 4% would bike, 26% would walk, and then about 22% of those trips would just disappear entirely. So for each of those alternative types of trips, there's a cost structure that's associated with that. You compare the cost structure of the alternative trip to the cost structure of transit, and that difference will either give you a cost or a benefit. As you can see on the red, those are some of the costs. Transit is more expensive than biking or walking, as you would guess, but it's much less expensive than getting a ride from a taxi or getting a ride from a friend or even driving in your car. So if you take that methodology and you apply it beyond transportation cost savings, or beyond vehicle operating costs to the other categories of transportation cost savings, such as travel time costs, emissions, safety, congestion, you can see for each trip what the wider economic benefits of transit are in terms of transportation cost savings. So putting those all together, we estimate that each transit trip provides its riders a saving of about 62 cents. Now that was one piece. If you remember, there was transportation cost savings and also the trip generation benefits. Those were the wider economic benefits of transit. This other piece, this trip generation benefits, these are the trips that potentially would disappear in the absence of transit. So you look at the frequency of those trips, and then you take that times the number of, by looking at trip purpose, the number of trips that would be made, and you can see that there are medical cost savings. When people go to work, it's almost like a double benefit. Individuals get to earn wages, but they also, many riders are transit dependent, and if they're not able to make it to their work destination, they may have to accept government transfer payments in terms of SNAP or TAMP benefits. So being able to make that trip enables an individual to make more money and potentially no longer need to receive those benefits or those transfer payments from the government. So then there's also commercial trips and social and leisure trips that have a benefit as well. At this time, I would like to hand it off to Transportation Planner from City of Raleigh, Brandon Watson.
Hey everyone, I'm Brandon. I'm gonna try not to cough a lot up here. I'm gonna go over a few slides over why economic considerations matter when it comes to transit planning at a bus system level, specifically the City of Raleigh Go Raleigh system. This map shows Go Raleigh coverage to various locations that are economic drivers in Wake County. These assets can be mapped and monetized to show the economic benefits transit routes provide to their ridership and the region as a whole. It includes just some of the major destinations such as shopping centers, employment centers, medical, and social leisure opportunities. As you can see from the map, a lot of the end of the lines of many of our routes serve these destinations. You can see some of the medical facilities in red, like Wake Med North and Duke Raleigh, some schools, universities in yellow, some of the employment centers and shopping opportunities like Triangle Town Center or Briar Creek in blue. And then there's a couple of parks that are pretty popular in the area in green. GIS applications for transit help us to determine the different economic and quality of life characteristics each route provides. We're also currently working on enhancing our performance measurement system to meet MAP 21 and FASTAC objectives, as well as City of Raleigh objectives like the city's strategic plan and internal departmental goals. We use different types of data to track and monitor how well we're performing in various categories, including passenger amenities and customer satisfaction, which we get a lot of that from surveys. Economic performance measures are important for us because they help us evaluate how we're contributing to the well-being of riders and the region's economy. We're currently in the process of determining which economic metrics would be the most beneficial for us. For example, it's useful for us to track what % of the region's jobs, wages, and gross regional product is supported through our transit expenditures. It's also useful for us to know the safety, congestion, and out-of-pocket savings our ridership experiences by taking transit. A good example of this is we were recently approved funding for the state's first signal priority system through Campo's locally administered projects program. It's basically going to be about 14 signals between I-440 and I-540 on Capitol Boulevard that would be a signal priority for the buses. Evaluating economic metrics are extremely useful in determining where to place projects such as that one, and if they are even feasible or not in our system. There's a couple of reports that are some good examples of what the state of the practice is for economic performance and performance measures in general. They're up here. It's the Transit Cooperative Research Program and the Florida Department of Transportation's best practices. We're currently looking at best practices of other urban transit agencies for performance measure adoption here at Go Raleigh. This slide kind of shows how funding ties in with all of this. The Federal Transit Administration provides funding through its Mass Transit Fund to public transit agencies across the country. Approximately $2.3 billion, or about 18% of their allotment, is provided through the New Starts and Extensions program, as you can see here highlighted in green. This program provides funding for bus rapid transit investments, which Go Raleigh and the other local agencies in the region are going to be competing for as a part of the Wake Transit Plan that Steve was talking about. There are 4 corridors that were included in that Wake Transit Plan: Capitol Boulevard to the north, New Bern Avenue to the east, to Wake Med, South Wilmington Street to the south, and Western Boulevard from downtown Raleigh to Cary. As you can see from the slide, economic development is one of the 6 primary categories the FTA uses to evaluate for awarding funding. In addition to federal funding, Go Raleigh also competes for state funding, and through the Strategic Transportation and Investment Funds distributed by NCDOT. These funds basically enhance the state's infrastructure while supporting economic growth, job creation, and a high quality of life. We compete for these funds through the local metropolitan planning organization, and you can see by the criteria highlighted in green the economic justifications, which are really important for Go Raleigh to secure this type of funding as well. A good example of this is the New Hope Road Transfer Facility competed for regional STI funds. It's basically going to create an off-street facility in East Raleigh for different routes that come through there. Each project that receives STI funding through the strategic mobility formula has different requirements for receiving funding, which can include cost-benefit analysis as well as economic competitiveness. Now I'm going to hand it off to Alyssa Randall, who is the GIS analyst and environmental planner with Planning Communities.
Thanks, Brandon. Okay, so as Steve said earlier, I'm going to discuss where we go from here. So we have this wider economic benefits of transit. We understand that. And now we want to take it to more of a micro level. We want to look at individual ridership and the benefits that they are receiving. So we want to get people excited to use public transit, and we want them to be able to understand the benefits that they're receiving. So how do we do that? We build an app, of course. People love apps. So this is something that anybody can access. You just download it to your phone, and it would be similar to kind of a carbon footprint calculator if you've done one of those before. So basically how we go about building this. So we're in the very beginning phases of app development. And the meat of it is going to be the actual existing networks, so the transit lines and the transit stops, as you can see up here. And then we use a tool such as Network Analyst. So the rider would put in their origin and destination. So I'm getting on the bus at this stop, I'm getting off here. Using that Network Analyst, it's going to be able to map the distance. And using the distance, that then gets put into the spreadsheet that Steve talked about earlier that's calculating those economic benefits. And then it's going to calculate your benefits per mile on a per mile basis. And we also want to link trip purpose in there. So are you going to work? Are you going shopping, medical, leisure? Because again, all of those have a different level of economic benefit. So we want to have the riders see their own personal benefit and then how they are benefiting the wider region as well. So in creating these tools with agencies, what are some core steps and best ways to move forward? So with the last few minutes that I have, I'm going to make this interactive because you guys look tired. And I want to ask, if you were a user of this app, what are some things that you would like to see in it, right? I said we're in the beginning phases of app development, and I have all of these extremely smart people in one room. And so I would love to get some of your opinions and things that you would like to see as we progress through the development of this app. So, sure. Sure, yeah. So just to repeat, he said that we want to make sure that we are encompassing everybody and we're not forgetting about the dignity of the current transportation riders. Anything else? Yes? Definitely, I agree. So he said he wants to include the environmental aspects of it, highway maintenance, because economics is a very broad category. So to kind of hone in on these different things, I agree on the environmental side. Actually, in the back. Yep. Yes. Yeah, great feedback. So he wants the efficiency aspect put into the tool.
Imagine you're kind of visiting a city for a first time too, and you get ridership. How about just input of destination? So now, using the app to calculate which bus they need, and if you added to that, obviously where the bus is, maybe pickup time. If you could actually utilize the bus and then project that data into the app, and now you've got people actually using it. Not only might give you the information you want for the purpose of the trip,
Yeah,
or perhaps a reward system that you've made 6 trips, here's a free trip that you can participate.
great feedback. Yeah, so he said to have to put in kind of like rewards for if you've done so many trips, and then to kind of put in the bus logistics as well. So put in times that they're coming, where the stop's at. Great information, yeah.
Maybe you could also provide types of infrastructure that can work here, like maybe provide sidewalks to the highway center spots or the destination, because sometimes you get off the bus and there's no sidewalks, so you have it's very dangerous sometimes. So,
Yeah, great stuff. So including that multimodal, those multi-use paths, that kind of thing. Yeah, great stuff.
I guess you kind of build what you said, kind of maybe have like within half mile, quarter mile, maybe activity centers or something. There's commercial opportunities or park nearby or something. So I might not know that. So if I get on the bus line or something, I use your app, I can get to the destination. Like, oh, okay, cool, I know this is here. So that takes them across the road on the drive or takes me around that way.
Yeah, so including places of interest, destinations.
So in North Carolina, a lot of our transit agencies are on rural areas of the state. Providing this kind of information and response transportation would be valuable because a lot of people do it every day but don't really know what the impact is.
Yeah, demand response transportation. Yes.
Maybe being able to share it with someone else. If I have someone coming in from a different state, give them the direction of the bus they can take to get my place.
Yes, good stuff. So being able to share it.
I was going to piggyback off that. Somehow making it like social, right? Like so you get a chance to maybe build social capital around the riders, maybe some data on like how people want to be on the bus or the rider. I don't know. There's some way to try to make that connection.
Okay, yeah, social capital aspect. Sure. Yeah, last one.
Okay, so, I know certain routes, not just in transport, but within the city, at 6 times a day, you could be waiting at a stop for a bus to pass. And if you could know ahead of time that, the next bus service doesn't have during the through line, you can plan accordingly. That would be something I would want to kind of keep track of.
Yeah, so maybe like current ridership numbers. Yeah. All right, well, thank you for all of your great feedback. That's awesome. We're going to take all of it back with us when we work in developing this app, so you guys are rock stars. And then at this time, if you guys have any last minute questions, anything you want to throw in, I know we're running close on time. All right, well, thank you so much. Oh, sure.
So if you had to
All right. Thank you, guys.
And thank y'all very much. Pull yours up and I'll start your introduction. That's not long. Yeah. All right, next we've got Walter Jenkins. He's with the City of Charlotte, with the CAT system, Charlotte Area Transit System. He's served on leadership team for code for Greensboro, and his work focuses on the management and analysis of transit operational data. Over the years, he has been a strong advocate for open data standards, and open source GIS. He's currently working on the data management and analysis for the CAT's bus rail study and the CAT's comprehensive operational analytics analysis called Envision My Ride. So welcome, Walter, and thank y'all very much.
Thank you. Like you said, my name's Walter, and I really love data, like a lot. Anyway, so today we're going to be talking about what is an open data standard, some real examples, how this fits into smart cities, and what implementation actually looks like, and some takeaways. So first off, we're just going to start with a general description of what open data is. So open data is the idea that data should be freely available to everyone to use and republish as they wish without restrictions from copyright, patents, or other mechanisms of control. Now, a number of different cities, I'm sure you guys know, have open data portals. There's Charlotte, there's Wake County, there's the city of Asheville, there's Greensboro, and if I left anybody else out, I apologize. So this is Steve Adell, and he said this once. He said, often open data is hard to compare to other sources, even across administrative departments located in the same building. Open data from more than one source has to be aggregated, normalized, cleansed, checked for quality, verified for authenticity, and validated for terms of use, a huge expense before it can be analyzed. That in itself is a huge project that you all would have to do in order to take the next step to build that application or run that model or do an analysis on what is the economic benefit of transit within your community. So open data standards is kind of the middleman between that. This is somewhat of a solution. It's a set of standards in which open data is formatted to improve the quality, effectiveness, reliability of data that includes, but is not limited to, data licenses, data quality, data versioning, metadata, data vocabularies, data formats, and data commonality. And I think that's my last definition. So let's talk about real life. Okay, so let's travel back to the dark times of the internet in 2005. There was this transit agency called TriMet, and what they wanted to do was they wanted to be able to take operational data, what the buses do, and the trains and the ferries, and it's a very complicated system. They wanted to take all of that and put it into a file that computers could actually understand. It just turns out that Google, at the same time, was trying to do that exact same thing, but they were looking for a partner. So Google and TriMet got together and put together what is known as the General Transit Feed Specification. And if you guys don't know anything about General Transit Feed Specification or GTFS, I highly recommend going out to your transit agencies and looking up that data. So GTFS is a series of 11 files that can translate what transit actually does on a daily basis. And now, granted, this is only fixed route data, so it would have to be reoccurring all the time. And like I said, it's machine readable, and it's in CSV files, very easy to open. You can open it up in Excel. And so these are the 11 files that make up everything in a GTFS feed. So you've got your agencies, your blocks, your calendar. I'm not going to go through all of these. But this is kind of how they talk to each other. I don't pretend to understand how you would even begin to write a script to actually understand this, but anyway, it worked. So they put it on Google Maps, and they were able to route everything all together, and the people rejoiced. And every city in the country wanted this data. They wanted Google to design their feed. Well, in 2006, 1 year later, they actually put together the GTFS reference page, which is a fantastic reference page. If you ever want to know everything about GTFS and more, I highly recommend going to this page. It's a very detailed documentation of everything. And it worked. So it is now a global standard, not a U.S. standard, not a North Carolina standard, but a global standard. This is, I think, probably from like 2012. These are all the cities that have actually adopted a GTFS and are on Google Maps and on Google Transit. And I just want to emphasize that when we think about GIS, we think about lines, points, polygons, raster imaging, but transit is so much more complicated than that. It's a series of times, and the route might not go down this street at this particular run time because of a dump truck or something. But it's more like this. It's about the times. It's about the frequency. It's about the access of the people. What can you actually get to? It's not lines. It's where people walk. This is a fantastic tool. If you guys are interested in doing analysis on transit, this woman out of Esri put together this suite called Yay Transit. And this is a great web page that's actually showing how well are people served by transit. So this is a analysis of frequency and the quarter-mile walk buffer using network analysts to display access within transit for every single stop. And as well as developers. Developers can utilize this data. It's very lightweight, friendly, can be posted and digested very easily. Somebody actually did design an app called iNap, and you can actually wake up before you get to your station that you need to get off. I thought that was pretty great. So GTFS real-time. This is the second open data standard that Google came up with for transit. So this is a small text file. It's a GeoJSON file. It's hosted on the Google Transit Partner website. It's more than just for Google. It could be used in any application. It could be used for just advising that there is a problem with a stop or there's an event going on. It's completely documented. It's pretty easy. There's 3 types of the feeds. So there's the service alert feeds, which basically just say there's an incident going on, like a detour or a move stop or special event, or God forbid there's a riot going on or whatever. You can actually disseminate this data out to the public, and it will display in Google Maps, alerting the passengers that there's something going on. And the trip updates, this actually works with GPS devices or AVL data, and then it uses the GTFS and recalculates the amount of time it would actually take for that bus to get from point A to point B, giving you an update saying bus X is going to be delayed 5 minutes. And then there's also vehicle positioning. This is where, obviously, you would be able to see the vehicles on Google Maps, and it displays it in XY coordinates. I have yet to find an example of this. I'm not sure how many people actually have done this. So what about roads? What about road closures? This is something that cities deal with all the time. So this is an RSS feed from the city of Greensboro. I took a screenshot of it. This is how they disseminate information. You can get an RSS feed from the city of Greensboro just like this. But you know what? It's not geographically tagged. there's no way to put that on a map or put that in an application. How does it communicate to Google, or how does it communicate to Here Data, or what have you? Well, there's this open standard called Open 511. Highly recommend you guys look it up. They're out of Canada, and basically what they do is they put together a GeoJSON file that has all of the road closures or detours for a city. So it's hosted on the city's website, and like I said, it's a GeoJSON file. It's pretty easy. It's more than just for Google. It's for applications. It's for your internal processes. And like I said, it's in computer-readable format. So it would kind of look like this on a map, but it's more like this. I've seen a couple other people show code. I think we're getting more comfortable with it. I think that's good. But also, it's very well documented, just like the GTFS feed. It's documented. It's the same. It's very easily spelled out. So you're able to turn this into this. And I'm going to just walk through how this is actually put together. So first off, you have the description. It's word by word what's going on, except you have a heading and a description tag right there. And then you have the times, and these are predefined fields that you found on the website. When was it updated? When was it created? What's the severity? Can you give me some HTML links? And then you've got attachments, so PDFs, people who don't necessarily know what's going on. Maybe you want engineers to know what's going on and disseminate that information in an email or what have you. And then you also have the geography. So this is the GeoJSON part of it, and it's just points that make up a line. So it's nodal. And then, of course, time constraints, because, maybe South Boulevard isn't going to be having construction during rush hour. It's just going to have it during, lunchtime. So it basically allows us to communicate all of these things on our cell phones, on our computers, to our staff. So Charlotte actually is teaming up with Waze, and we're actually going to be sharing some of our road closure data, and it's not a Open 501, but it's pretty close to the Open Data Standard. And so they're going to be able to digest our information, and in return, they're going to be sharing some of their incidental data that they get, and we can use that in the traffic center for our city. So we're able to catalog that data and use it in the model and whatnot. So why would you want to do this? Because you've got people out in the field, because you've got buses that run down the street, because you've got other buses that run down the street, and you have fire, EMS, police. These are people who need to know what's going on. This is how you become a smarter city. So just to give you an example of what you might be able to do, let's say GTFS meets Open 511. So you've got the geography. This geography talks to this geography, does a selection by location, and then it associates that, says, hey, there's a road closure. Maybe we need to tell somebody. What route is it? What agency is it for? We have an email. Why don't we just email the agency that needs to know this information and automate that process, and maybe even just automate the detour. This is just the tip of the iceberg of what you can possibly do with data and being able to have it in this digestible format. So why not do this for roads? Why not actually have a standard for roads that maybe Google puts together or OpenStreetMap puts together? So this is actually the standard that Google has on their website, and you can actually share your Esri shapefiles with them. And it's got a plain English how they would like to have it. Maybe that's not necessarily great for all of us, but there's also OpenStreetMap, and this is a free tool that you guys can use for routing, for online purposes, and this data is out there. It may be correct, it may be incorrect. It's completely community sourced. So, like I said, this is how cities get smarter, and this is the foundation of everything that we've been talking about, because it's all data. That's my name. Oh, any questions? Yeah.
So you may or may not be the right person for this question, but you said there was a lot of automation in this type of process. How would you deal with the offset of, jobs that do that all the time, or jobs that are supposed to do that?
That's a difficult question.
I was asked that before.
Yeah.
I like this automation, but
Right.
gain something, you do something else.
Right. I could go very philosophical with that and say that we all might be replaced by artificial intelligence in the next couple of years, and we should all brush up on our painting skills, because we might not have jobs. But I don't know. It's definitely a problem, but I think this is going to become the norm in the future, and I think that businesses are really going to want to see this kind of ingenuity from cities, and they're going to want to partner with cities like Waze has partnered with us. They're going to want that and expect that more and more. So open data standards, I think, is a really good way to jumpstart that process. Yes.
At the beginning of your talk, you were talking about how Google helped harmonize some of the transit data.
Yeah.
Do they only receive that from the municipality? I mean, we just went through like a bus redesign in Winston-Salem. The mapping's terrible. I'm like, how could this not be in Google already? How does that work?
How is it not in Google already?
I mean, so is Google like say it has to come from a certain address, or like we have shape files up with maps?
There are certain companies out there that actually produce GTFS feeds. So you might want to talk with your operations department about what suites they have to currently manage their scheduling. But yeah, basically the agency has to sign an agreement saying that they will upkeep this information, and that Google is allowed to digest it and speak on their behalf, basically. Yes, it has to run through the agency. Google will not just do it for you. Yes. He was asking about Waze and the process that we had to do. I'm not the best person to talk to about that, but Steven right here in the green shirt might be a better person to talk to. Any other questions? All right, well, I hope you guys have an awesome conference.